Good evening, everyone.
Good evening, sir.
Once revise what we have discussed in the previous class. Check once everything. Join with videos. Ashish, Navika,
Yes, sir. Just a minute.
Deepika,
So my camera is not working.
Krishna, okay. Tanya, no. Rajeshri,
Sir, just a minute, sir.
Tanya, you didn't join with video. Can you see what I am writing on the board? I can't hear you also. Bhanupriya,
Sir, if I on my video, I won't be able to hear you properly.
okay.
So I need to off it.
Vaibhavi, once check that what we have discussed in the previous class. Now I will ask questions. This is Ashish. Navika. Hello. Navika, can you hear me? Rajeshri. So that is the problem. So if you are in the video, then I can see that what I'm speaking, can you hear me or not? I call three names, no one is speaking. So is that means they are, can you hear me properly or not? I don't know. You won't respond that you are there in front of book or not. Even I don't know. It's not correct. So no one can hear me, right? Just Ashish can't hear. Navika can't hear me.
Sir, I can hear you.
Then I called you before also, no?
Yes, sir. I was just turning on my camera. There was some problem.
Okay. Vaibhavi,
Yes, sir.
what we have discussed in the last class? What we have discussed in the last class, man, everyone? That's all. I don't know that you are writing notes or not.
So we discussed.
So, So we discussed the third law of Newton.
Third law of Newton. After? Where's the last? Krishna, is it the last topic?
So first we discussed some more problems on connected bodies.
Okay.
Then we discussed, you just gave some points on Newton's third law.
Okay. What about PDF? Everyone, did you open the PDF once? Did you start solving?
Sir, I have started doing it. A little bit is left. I'll do it by today.
How many questions are there?
So 1 minute.
I called Ashish 3 times. Maybe Ashish can't hear me. I will I will keep in the waiting list.
So I didn't get any PDF.
Even I did get.
It is there in the Google Classroom, right?
Yes, sir, but I didn't get it.
I didn't get it.
The last PDF was like on 18 December, some WhatsApp images. That one I already saw.
Yes, sir.
I have attached one code or something. Like you've written something on that black.
That's all.
Yes, sir.
Krishna, about
Sir,
which? Krishna, new PDF is not there, no?
no, so whatever you have written on board, that's what even I have written. It is, I think, just one question which you have done.
No, it's not. Okay, I will ask Sir once because I sent the PDF. Sir didn't upload. I think in the way to upload. Okay, I will check once. Sir. Then today, listen friction. So what we have discussed in the Newton class, just once we will recap. Newton's laws. Force and Newton's laws. So we discussed about the force, types of force, after force and types of force after. So the side head is in the notes. Types of force. In the types of force, contact, non-contact, and everything we discussed. Contact, non-contact, Ashish. Navita.
Yes, sir.
Rajesh, can you hear me?
Yes, sir, I can hear you.
Ashish, now can you hear me?
Yes, sir. Can you hear me now?
Yes, I told you now. If you want, can you hear me from
Now I
start?
can hear, sir. For me, I was trying to speak, but I couldn't. You weren't able to listen. Some mic problem was there, I think.
No, still even on mic. No, how it will be problem? Okay.
No, sir. The mic, it was not coming. It was like hanged. The system was hanged.
Okay. So third one, contact forces examples that we have studied, non-contact forces examples that we have studied. It is the ending of the lesson. So in the ending of the lesson, what we have studied in the lesson, everything I'm explaining. So after Newton first law, fourth concept is momentum. Fifth one is relation between momentum and between momentum and
Kinetic energy.
Kinetic energy.
kinetic energy. We have discussed about change in momentum also. Change in momentum and problems on this. Seventh one, change in momentum of the second law, impulse. Sorry, second law, second law of Newton. Eighth one, problem impulse. Ninth one, free body diagram. Free body diagram. Tenth one, problems. Based on second law. 11th one, based on second law, that are one is contact bodies. Third, second one, contact, and one more is what?
Non-contact.
Huh? Contact bodies and then this law.
Non-contact.
Oh, God. So we did problems on second law of motion. One is contact bodies. Next one is connected bodies. Connected body sounds. Contact bodies and connected bodies. So these are the topics that I have discussed, force and Newton's laws of motion. And the 11th one is third law of motion. That's what I have discussed. Okay. Am I clear what I discussed? Is it everything is there in our notes or not?
Yes, sir.
Let's see one more concept. So 11 concepts. This you have to write in the one page. What are there in our notes? So these are the topics are there in our notes. So which topic? If I ask that topic, you can open and you can show me. Next 12th concept today. I am going to say one more concept. Look at this. Can I?
Yes, sir.
Frame of reference. That is the 12th concept. Frame of reference. So frame of reference, actually it is one of the idea held from observation. So it is the idea arranged from the observation. So one of the person, one situation, any one situation, okay, one situation is observing by two persons. One person is observing from here, very near. One more person is observing from some far. So situation is same, but what he is observing, is it can he observe the same thing properly? I can't hear.
No, sir.
No, right? Suppose one of the person is in the aeroplane. One of the person in the aeroplane. Okay. So now what happened? So he dropped one of the stone. He dropped one of the stone. So one more person is on the ground. One more person is on the ground. One of the person is in the aeroplane. So he dropped the ball. When he dropped the ball or stone or ball, he dropped it. So he is observing from the aeroplane. So to him, this ball looks like it is falling in the straight line. It's falling in the straight line. But those who are observing from the ground, to him, this ball is falling in this path. So situation is only one, that is ball is falling from the aeroplane. But what he is observing, that is different. So why it is different means, because his reference point is at some place, his reference point is in somewhere. So reference point from where you are observing the situation, that point is called reference point. That frame is called reference frame. Okay. Now, according to us, his frame of reference is in the motion. According to him, the frame of reference which he is observing from there, it is at rest. Ground is at rest, no? So its frame of reference is rest. His frame of reference is in the motion. So what he is observing the situation is different. What he is observing the situation is different. Why it is different means because of the frame of reference. So from where he is observing, that is called reference point. That frame is called reference frame. Am I clear? Hello.
Yes, sir.
So can you tell me what is the reference frame? Anybody can say what is the reference frame? Krishna, can you explain what is the reference frame? What did you understand from the reference frame?
Yes, sir. When a person is the the place where the person is standing.
Hmm.
Okay, so I'll explain it. Suppose, there's a person on the ground and one person is on the aeroplane.
Yes.
So for the person who is on the ground, he's at rest.
Hmm.
So he'll observe the object in a different way.
Hmm.
And the person who is on the aeroplane will observe the object in a different way, but it is the same object.
Yes.
So it depends upon
From where he is observing that.
the place where he's observing from.
That place
Is it
is called
in
what?
frame of reference?
That's all. So reference frame is an idea held from the observation. So why it is happening means because they are observing the situation from the different points. So the different situations are there. So but situation is same. Two persons are observing differently because of the frame of reference. So concept is clear. What is the frame of reference? Suppose one more person, if he is observing from some other place, again he can see some other way, right?
Yes, sir.
Like that, from where he is observing the situation, that is called reference point. That frame is called reference frame. Okay. Now I'm going to write a reference frame definition. Just write down. But it is the idea and from the observation only. It is not. We are not taking this from anywhere. So it is just from idea. So a system of coordinate axis, a system of coordinate axis which defines the position of the object position of a particle, position of a particle or an event, or an event, or an event, one dimensional, or an event in 1D, 2D, 1D, comma, yeah, 1D he can observe, 2D also he can, or 3D also. 2D or 3D also. 1D is common. 2D or 3D also. 3D space is called frame of reference. Frame of reference. So frame of references are two types. One is inertial frame of reference. Second one is non-inertial frame of reference. Non-inertial frame of reference.
So I got disconnected. Can you hear me?
Hmm.
Yes, sir. Just a minute. I arrived.
Sure, sure. Trista, did you understand what is the frame of reference?
Yes, sir.
How many types of frames of reference are there?
2 types.
One is
Inertial frame of reference and other is non-inertial frame of reference.
yes. Now we are going to discuss what is inertial frame, what is non-inertial frame, every topic. If you take Newton's laws of motion, each and every topic that I will explain. Navika,
Yes, sir.
what is the momentum, Navika? Hello? Hello? Navika, can you hear me?
Yes, sir. Can you hear me now?
Yes, I can hear you.
Sir, momentum is mass into velocity.
Tell me a few words. What is the use of the momentum? What will you learn from the momentum? Mass into velocity, that's all. In which way it is useful to us? Priscilla,
Yes, sir.
in which way momentum is useful to us?
Sir, momentum is quantity of motion.
We can find quantity of motion from the momentum, right?
Yes, sir.
See, everyone, if we join with videos, you will learn very nicely. I don't know why you are acting like this. Even small mobiles also, so many members, they are joining very happily and learning. So I think, see, whatever I am explaining, that is my responsibility to explain. After completion of the topic, means today's class or some any day class, after you have to practice. Without practicing, if you attend to my one more class, classes will go on like that. But what is the use that you are joining your 1.5 hour you are wasting here? It's not correct. I can't see you properly that because your videos are not on, so that I don't know what you are writing or reading. When I'm asking question, is it can you hear or not? I can't find anything. So I don't know why you are acting like this, but notes should be very, very careful. I will check notes what I'm giving because each and everything I'm writing on the board. So that I need my notes and I told you now, I will ask questions like this now. I started asking questions. Those who are not answering immediately, then I am writing here some names also. Later I will give the result to the sir. Done. The frame of reference. Now we are going to discuss about now inertial frame of reference. So what is inertial frame of reference means? The frame must point. The frame which is at rest or uniform velocity. The frame which is at rest or uniform motion. So those who are observing the things like situations, that observer are in the frame. Which frame? That frame may be at rest or may be in uniform motion. Both frames we will call as a inertial frame only. In inertial frame, Newton laws of motion valid or apply Newton's laws of motion valid. Here Newton's laws of motion is valid. Or we write motion are applicable. Are motion are applicable. Applicable. It is also called unaccelerated frame. It is also called unaccelerated frame. One point, second point, third point. Examples: lift is at rest. Lift is moving with constant velocity up or down. So this is called inertial frame of reference. Trisla, am I clear what is inertial frame of reference clearly?
Yes, sir.
Now tell me, one of the person is moving in the car. That car is in the uniform velocity, so that he is in the inertial frame or non-inertial frame.
Inertia.
Inertial, because car is moving with the uniform velocity.
Yes, sir.
Next one, non-inertial frame. The frame which is in acceleration. The frame which is in acceleration. In this frame, Newton's laws of motion not valid, not applicable. Not applicable. All accelerated or rotated frames are non-inertial only. Examples: accelerated car on road, merry go round. Clear?
Yes, sir.
So just a minute.
Note. Non-inertial frame we can make as a inertial frame by applying by applying pseudo force.
So what is pseudo force?
Definitely, I'll explain right there. Applying pseudo force. That's what I think. Even Newton's laws of motion, we can non-inertial frame we can make as a inertial frame by applying the pseudo force. Krishna,
Yes, sir.
understand?
Yes, sir.
Nice symbol, right?
Yes,
Very
sir.
tasty it seems.
Yes,
So
sir.
non-inertial frame also we can make as inertial frame. Non-inertial frame means Newton's laws of motion is valid or not?
No, sir.
Not valid. But by applying pseudo force, after applying the pseudo force, we can make as a inertial. Okay?
Yes, sir.
Newton's laws of means first law, second law, third law is there, no? That laws. Okay?
Yes, sir.
Okay. Look at this. How? So what is pseudo force? How to apply that? Now I'm going to do that. Now, one of the car is moving with the acceleration A. Car is moving with the acceleration A. Now car is in the inner. Now that person is in the inertial frame or non-inertial frame?
Non-inertial.
Non-inertial frame. So what I am going to do, I am going to apply force which is opposite to this force. So I am going to apply force in this direction. This is just opposing force. We can say that opposite force. To any acceleration, if I give opposite acceleration, same amount. So look at this. Nothing is there. Body of mass m moving with the 2 meter per second square acceleration. So in this direction, 2 meter per second square acceleration car is moving. Same 2 meter per second square I will give in this direction. Then it is a thrust or it is uniform motion. It can be anything, right? It can be anything. Either it is a thrust or uniform motion also.
So, but it will stop, right?
Yeah, mostly it will stop, right?
Yes, sir.
See that now, that time we will say it is the inertial frame or non-inertial frame. That is what? Just if you apply acceleration opposite to the body acceleration, that acts like a pseudo force. So pseudo force is nothing but just opposite force or not opposite force. Okay, Ashish, am I clear?
Yes, sir.
Pseudo force is nothing but which force? Opposite force. Opposite force. So opposite force means, can you give an example? Suppose,
Friction.
yeah, one force, yes, one force, one of the body is moving, okay, in the circular path. Inside the center, which force will act?
Centripetal force.
Centripetal force. To the centripetal force, opposite force is what?
Electrostatic.
No. Centrifugal force. Did you listen that name? Centrifugal.
Yes, sir.
Centrifugal. So centripetal force is F is equal to mv square by r. Centrifugal also same, but m minus mv square by r. So inside force equal to outside force, so that this body will be in the inertial frame. Am I clear?
Yes, sir.
So pseudo force act always opposite to the body acceleration. Pseudo force is always act not to pseudo force always act opposite to body acceleration. Clear?
Yes, sir.
So frame of reference is the my 12th concept. 13th concept is apparent weight. Apparent weight. Of a body. Apparent weight of a body moving in elevator. It is my 13th concept. Apparent weight. So apparent weight. Suppose, listen carefully. First incident. It is the lift. It is the lift. So elevator. It is the elevator. Okay. Feel like it's the elevator or lift. Nothing will happen. Anything. So now one person is here. Maybe so many members of you, I think You experience this thing, but you don't know that what is really is happening. So when this elevator is moving with the acceleration upward direction, is it this person will feel more weight or less weight when it is going up?
Less weight.
No, definitely you will feel more weight when you are going in the lift upward direction. Once, if is there in our apartment that lift and all, you can check once. Okay, definitely when lift is going upward direction, you will feel very heavy. You will feel very heavy.
Sir, but when it comes down, it will be like very light.
I am telling that situation is going up, no?
Okay, so then it's
Yes, going up. Second situation is when the elevator is coming down. So when the elevator is coming down, how we will feel? When we are going down, we will feel weightless, right?
yes, sir.
Third situation is elevator is at rest. When elevator is at rest, how we will feel? When elevator is at rest, how we will feel?
Normal.
Normal. Original weight only, its weight. Original weight itself, apparent weight. But here, when he is going up, what is his weight? More than that, he will feel. Here, what is his weight? Less than that, he will feel. Here, actual weight, he will feel. Okay? So, one more case also is there. Definitely, I will say that. Fourth case. Okay? So, start. Case 1. Case 1. What is the case 1 that I am taking? If lift is at rest, lift is at rest, or moving with constant velocity, moving with constant velocity, then body weight, then body weight, then body apparent weight, apparent weight. Look at this. Apparent weight is equal to original weight. Why? Why it is happening? When the lift is at rest, apparent weight is nothing but original weight only. There is no any change in the weight. Why it is happening? Everyone knows now how to draw the cuboid diagram. Person is here. So downward direction, what is acting on the person?
Gravitational force.
So mg. Upward direction, what is acting on the person? Person. Downward direction is mg. Upward direction, what is acting? Hello. Tisla.
Yes, sir.
What is acting upward direction?
The tension.
Oh God, where is the tension? Where is the ropes here? Just he is standing in the elevator. He is standing in the
Yeah,
lift.
that is normal. Sir, but is it only in the case of ropes?
Case of rope not. Why case of Don't consider the rope. What is the rope is there? Where he is? He is in the box. He is in the elevator, right? You
Okay,
have to
sir.
think about the elevator. You should not think about the outside what is happening, right?
Okay, sir.
So normal force means reaction force is acting. Normal reaction. Is it lift is going with acceleration?
No, sir.
So acceleration equal to 0, right?
Yes, sir.
So after drawing the free body diagram, what is the next step that you have to do?
Calculate force.
So second step, F is equal to ma. So acceleration is there?
No, sir. 0.
0.
No force.
So F net how much? F net how much? Tell me. F net how much? F net equal to how much? Anybody? Array, F net. Don't you know how many forces acting?
2.
So what is the F net now? N plus mg, yeah? Or n minus mg? N plus mg or n minus mg? Okay, don't give answer. Be like that.
So n minus mg.
Yes, ma'am. N minus mg equal to 0. So n equal to mg. N equal to mg. So its weight is normal. Same. His weight is original weight equal to apparent weight. No, there is any change here. So apparent weight will be equal to 2 weight because elevator is not there acceleration to the elevator, so that's 0. So F net means how many forces? That means 2 forces. Both forces are equal and opposite, so that n minus mg equal to 0 I written, so n equal to mg.
So should we draw that law?
Obviously, no. Just one box and some something you have to keep inside the lift. It's not big
So
diagram.
how
Right?
many cases are there?
4. Now case 2.
So just a minute, right?
That's why you didn't understand.
I got it, sir.
Then why didn't you say how many forces acting is very silent, huh?
Sir, I knew it was 2 forces, but I got confused with the formula. Like,
Formula just we will write.
is it n plus mg or n minus mg?
Why forces acting opposite direction? Force is a vector quantity, no? It having direction also, no?
Yes, sir, then I got it.
Case 2. Lift is accelerating up. Lift is accelerated up or retarding down. Lift is accelerating up or retarding down. Retarding means
Opposite of acceleration.
Negative acceleration. Okay, retarding. Retarding down with the acceleration. Acceleration A. Acceleration A. Then apparent weight. Apparent weight. So again, free body diagram. Lift is going upward direction. Now tell me free body diagram here. So on downward direction, what is acting?
Gravitational.
So downward direction is mg. Upward direction,
Normal.
normal force, and acceleration.
Upward.
So F net equal to ma, right?
Yes, sir.
F net how much? F net how much?
Sir, N plus mg.
One is in this direction, one is in this direction, no?
Yes, sir. Yes.
So now n equal to ma plus mg.
Mg.
So m equal to m common a plus g. Actually mg only, but here something is adding, so that its weight is increased or decreased.
Increase.
Increased because n equal to mg only, but something is adding here, no? So some value is adding. So normal reaction increases. Normal reaction increasing means weight is increasing. Is that clear?
Yes, sir. Done.
Case 3. Lift is accelerating downward. Lift is coming downwards. Lift is coming. Lift is accelerating down or retarding up with acceleration A. Now draw the free body diagram. Tell me. Upward direction, what is there?
Normal.
Normal force. Downward direction, what is there?
Gravitational.
Downward direction again, what is there?
Acceleration.
So write F net equal to ma. F net how much?
mg minus n.
Mg
Minus n.
equal to ma.
Ma.
So mg minus ma equal to n. So that n equal to m common g minus a means actually originally is equal to mg, but minus something you are detecting. So original weight will increase or decrease.
Decrease.
So apparent weight is this. This is the apparent weight. Apparent weight decreases. Tell me, is original weight how much? Original weight how much? Trisla, what is the original weight?
Sir, original means mg.
I didn't get.
Sir, original weight.
Original weight how much? How much original weight?
Sir, originally. Sir, means when there is no acceleration.
Yes, ma'am. Original weight how much when the lift is at rest?
Mg.
That's all. Now mg is less or mg minus a is less?
Yes, sir.
Which is less? Mg is less or mg minus a is less?
Mg minus a is less.
So that weight is decreased, apparent. But originally he has mg only. But due to the motion of the elevator downward direction, he is feeling weightless. So that how much weightless means minus g minus a weightless. Okay.
Yes, sir.
Fourth case. If lift is falling, freely, lift is falling freely. The lift is falling freely. Freely means what is the acceleration? If any body is falling free, like without any applying force, if any body is falling down, what is its acceleration?
9.8 meter per second square.
Right? So g, right?
Yes, sir.
So g acceleration. Now lift is coming with g acceleration. Person is here. Now tell me, free body diagram. Lift is falling freely means a equal to g. That is the meaning. So tell me the free body diagram.
Downward is gravitation. Normal. 9.8.
So f is equal to
MA.
ma na.
Sorry, mg.
Mg.
mg. F net means how much? F net equal to how much?
Mg minus n.
Mg minus n equal to mg. So mg minus mg equal to n. How much you will get?
0.
So what is his weight? Apparent weight how much?
0.
Any body is falling freely, we will feel that it has no weight. Right?
Yes, sir.
Yes.
So just a minute.
When lift will fall freely, tell me?
When the cable breaks.
Yes. Clear? It is my 13th concept in your force and laws of motion.
Yes, sir.
And whatever I am explaining, it's not a matter that if you don't prepare, then whatever you are attending to the classes, 1.5 hour that you are wasting, you are listening the class, everything will become waste. So first you have to habituate reading, and before attending to the class, 10 minutes before, you have to start reading. You have to start reading. So after, you have to attend to the class. Without reading, if you attempt, no use. Don't attend like that. So many times I told you. See, those who will prepare very nicely, they can remember so many days and they can gain more knowledge about the subject. Without reading, simply if you attend classes, no use. Time waste. So by that time, happily you can sleep. So at least you will get health. Here, if you don't listen, if you don't follow the rules, what we are saying, simply if you attend to the class, what is the use? Huh? You should not do like that. Every day you have to prepare. Problem on 13th concept. Try to do this. A mass of 1 kg attached. A mass of 1 kg attached to one end of the string. Attach it to one end of the string. One end of the string is first lifted up. Is first lifted up. You can understand. Lifted up means you can understand. Lifted up with an acceleration 4.9 meter per second square, and then lowered, and then lowered, and then lowered with the same acceleration, with the same acceleration, with the same acceleration. What is the ratio of tension? What is the ratio of tension? What is the ratio of tension in the string? In the string. In two cases. In two cases. Anybody can solve and tell me now immediately, or you require so much time to do this? I guess you have idea when body is going with acceleration, when lift is going upward with acceleration, what formula you have to use, you know? When the lift is coming down with acceleration, what formula that you have to use, you know? So very easy to calculate the things. Anybody can say answer fast. This much time. What formula will you use? Speak anybody. What formula will you use?
So first n equals to m a plus g.
So n plus here put t. Why? Because he's asking tension, no? So t equal to
Yes, sir.
m
A plus g.
g plus a. Next.
Then
So if it is 1, so t equal to m means how much? 1.
1.
G means 9.8,
9.8.
4.9. Calculate this. How much you are getting?
14.7.
14.7. This is the first one. Second one, what will you do?
N equals to m g
T
minus
equal
a.
to m into g minus a. Done. T equal to 1
1
into 9.8 minus 4.9. You will get 4.9, huh? 4.9.
Yes, sir.
It is T1, it is T2.
Then
T1
the
by T2.
ratio.
Then the ratio how much? 14.7 by 4.9. How much will you get? How many times? 4.9 plus 4.9 is 9.8. 9.8 plus 4.9, 14.7. So 3, 1, 3 is to 1.
So 3:1.
Yes, very good. Done.
Yes,
What
sir.
is there? Very easy. But the concept that you should get to know when they are asking this type of problems. Okay.
Yes, sir.
Homework problem. And today we will upload even PDF also. So do that. Without doing, don't enter into the class. It's not good. It's not good actually. Student means whatever teachers they will say that you have to follow, because we don't say anything that is harm to you, right? Whatever we are saying, that is for your best future, right? So
Yes, sir.
please follow the whatever whoever the teacher, if they are saying something, it is better to follow that. Okay, but because it is gives the best future to you. One more question. Homework. The apparent weight of a man in a lift is W1 when lift moves upward, upwards with some acceleration, and is W2 again when it is accelerating down with same acceleration. Find the true weight. Just practice. Just try to solve this. If you don't get us, not a problem. But you have to try. And acceleration. Clear?
Yes, sir.
Yes, sir.
Yes. So please follow the rules for that what we are doing, what we are saying to you. Very good for your future. And just try to solve. If you don't get, don't see anywhere. Okay, don't see anywhere. Try. You are getting or not, we will discuss in the next class. But if you see somewhere and if you do, it does not make any sense. So don't do that type of things, okay?
So can you please move?
Do you write the question?
Yes, sir.
So today's concept is clear, right?
Yes, sir.
Yes, sir.
What are the concepts that we have discussed today?
So frame of reference,
Very good.
then apparent weight of a body
In
moving in
the
elevator.
yes. And what it is the concept number 13th and 13th, right?
Yes, no, sir. 12 and 13.
13th concept. Up to 13th concept we completed. Okay. One more concept also is there that I will explain. Okay. See you in the next class.
Thank you, sir.
Yes.
Thank
Thank you, sir.